and we're going to be talking about the difference between hydrophobic and hydrophilic molecules. So for starters, we're going to talk about hydrophobic. You've probably heard people talk about they're either hydrophobic or they know somebody who's hydrophobic. I tend to classify myself as that. I don't really like water. I don't enjoy swimming, and it's just not my thing. So hydrophobic, as you can probably guess, is your failure to mix with water, by simple definition. The molecules that don't mix with water, a lot of their characteristics tend to include being nonpolar. That's simply because they prefer to combine themselves with other neutral molecules or other nonpolar solvents. So a solvent, which is not to be confused with a solute, is like if you have hot cocoa mix and then you have milk, your milk is going to be the solvent, your hot cocoa mix is going to be the solute that you add to it. So in this case, water is the solvent, but it is a polarized chemical structure. So now I do have an example. So this is a little guy of water, and there's actually some oil on the top already, but I wanted to kind of give a visual example of what happens when you pour a hydrophobic substance into, which this is a non-polarized, the oil is considered non-polarized. You also have like fats, greases, waxes, so on and so forth, kind of are characterized under the same category. But when you pour the oil into the polar solvent, which is the water, you probably saw that it created all these little clusters down at the bottom, and then they rose to the top, and that's because they're not mixing. Well, all these little clusters that the oil makes in the water, because it's not mixing, instead they clump together, those are called micelles, which are molecular clusters in colloids or colloids. I've heard it enunciated either way, so whichever you prefer. And then we're also going to talk about hydrophilic, which is the exact opposite of hydrophobic. This is having a tendency to mix with, dissolve in, or be wetted by water. It's a strange definition, but I have, through my research, I found that is a common description. So of course we then talk about the characteristics of hydrophilic, which is pretty much the exact opposite of hydrophobic. So you are going to be looking at things that do dissolve in water. That's going to be sugar and salt, pretty much any starch, even cellulose. So these tend to be polarized, obviously. Let's see. I just want to make sure that I am following the prompt correctly. I also wanted to mention that it can also be called or referred to as charge polarized. Sorry about them. So charge polarized is essentially the same thing as saying that it is polarized or it has a charge, from my understanding. Please correct me if I'm wrong there. But because of this, we consider hydrophilic molecules capable of hydrogen bonding. So we all know that H2O is hydrogen with an oxygen, 2 hydrogen with an oxygen. So of course it needs to be able to mix with the hydrogen. That's the most important part. So let me just make sure that I've covered all my prompts here. Okay, so I kind of use this as my beaker of water, so I do hope that that is acceptable. And then, of course, I do actually have hot cocoa mix here, which in theory I could go ahead and mix into the water. This one already has oil in it, so let me grab. And you'll see the difference, actually, between the two different substances here. This is like a real-time science experiment. This is pretty cool. Okay, so this is cold water. I know that we're not supposed to talk about temperature, that wasn't in the prompt, but cold versus warm does matter, just because when you have a cold solvent, the atoms are not moving very quickly. So they're actually moving very slowly. If if it's frozen, they're not moving at all. So typically you find that things dissolve better in warm water because those atoms are going like this because they're so warm, and so it creates kind of its own mixing. I think it's fascinating. So I'm going to say mixing phenomenon because that's just, it's a cool concept to think about. So this is cold water, so I don't expect this to mix super well, but if you were to put like hot cocoa in here, it starts to turn like the water a different color, and that's because it's hydrophilic. So it's mixing in with the H2O that I have in here. It's not repelling it in any kind of way, which is what the hydrophobic is. So, well, thank you for listening, and I hope that you learned something today, and I will see you on the next one.